Have you ever experienced that a scientific journal asks you to make your data available together with your publication? Are you using a range of analytical tools to analyze your data, and would you see the benefits of having easier access to software and workflows, and even computing power? If you're interested in these and related questions, you will probably want to hear more about eBrains. The goal of eBrains is to accelerate the effort to understand the human brain in health and disease, and to advance brain medicine and technology. eBrains is an online web platform providing tools and services which can be used to address challenges in these fields. The tools assist scientists to collect, analyze, share, integrate brain data, and perform modeling and simulation of brain function. What is the role of the Human Brain Project in eBrains? HBP has developed and will continue to develop the eBrains tools and services. They are found at ebrains.eu. Is eBrains a mature platform? HBP has developed a range of tools and services. Many of these are already shared at the eBrains web platform, and more will come in the coming years. eBrains will become a research infrastructure, and to make sure that this will happen, 7 institutions in Europe have formed a new international non-profit organization, eBrains AI-SBL, based in Brussels, Belgium. eBrains distributed research infrastructure will expect to have participation from many more partners in Europe. The starting point for eBrains are the HBP platforms launched in 2016. Neuroinformatics platform, brain simulation, medical informatics, high performance analytics and computing, neuromorphic and neurorobotics. However, these platforms are now joined together in eBrains. eBrains consists of a base infrastructure with high performance and neuromorphic computing systems. It consists of tools and services and of data. The research community can have access to all the layers in this structure, specifically to the service for sharing data, including data curation and anchoring of data to brain atlases, to a knowledge graph search interface allowing users to find and access data and models, to analytics workflows to work on a multitude of data and extract key features, to model building tools benefiting from the data derived from the analytical workflows, to simulation engines allowing models to be tested and producing outputs that in turn can be compared with data from real-world observations. The high-level support team, HLST, supports the users, fielding their inquiries, solving problems, and in some cases providing in-depth support to adapt the tools and services to the needs of users and new use cases. The voucher program facilitates in-depth modifications and extensions of these tools and services. This program increases the capacity of the HLST and has supported a broad range of projects and will support more in the future. eBrains now has the following 6 service categories: data and knowledge, fair data and models, brain atlases, brain modeling and simulation, closed-loop AI and neurorobotics, medical informatics, and interactive workflows on high-performance and neuromorphic computing systems. First, the data and knowledge fair data services. This is about curated and shared data, publishing data. A set of comprehensive tools and services for sharing data and models, providing long-term storage of the data, citable DOIs, licenses for use describing the terms and conditions, and metadata and descriptions making the data findable, interpretable, and reusable using a knowledge graph system. This gives credits to the data providers, creates greater exposure of the data, and access to the shared data for increased productivity. So here a summary of the advantages from data management support, long-term storage, proper credit, reuse opportunities, collaborations, and of course, funding opportunities based on the wishes of funders to have these type of open data. All types of data can be shared, and we are seeing a rapid increase in the uptake of this system. The curation of data is basically about connecting metadata to a knowledge graph, scalable, allowing new types of metadata to be added in the future, connecting also the data to space, to atlases, and allowing the data to be used with various tools and workflows. The curation process has multiple steps. First, a curation request, which you will do at ebrains.eu share data. A curator is assigned. The data metadata are being organized with the help of the curator. There are different curation steps leading to a publication and a later follow-up with atlas integration and more in-depth curation. This is what a knowledge graph search looks like. As we can see on the left side, we have at the moment around 800 data sets in this system from about 900 researchers. You can search for various keywords and information, identify landing pages or data cards, and on these cards there is information about the methods, the various types of other metadata, description of the data, and access to download of data. Also possibilities for the data provider to have a temporary embargo, for example, waiting for a publication to be released. The brain atlases is another type of service. This is key to navigate the brain in 3 dimensions to find, contribute, analyze data based on location, much like geographical information systems. Detailed atlases of the human brain and of rodent brains, and soon also of non-human primate brains, will be embedded in this system. Brain modeling and simulation, integrated tools and workflows to create and investigate models of the brain. The brain modeling and simulation services provides workflows at multiple scales for modeling all the way from molecular to more large-scale simulations. Closed-loop AI and neurorobotics, connecting brain models to simulated bodies in a physically realistic environment. This is something that follows naturally after modeling simulation, also taking simulation all the way to embodiment. And new learning paradigms with massively parallel virtual robotics is becoming very important. The neurorobotics platform has in this regard several advantages by providing a virtually arbitrary number of parallel simulations. So, neurorobotics platform basically connects neuroscience to robotics. The medical informatics and medical brain activity data is another service category with smart solutions for accessing and analyzing clinical data. The medical informatics platform is currently installed at 30 hospitals across Europe. More will be coming. It is a system allowing federated analysis of clinical data. And next year we will have a new human intracerebral EEG database and analysis services with unique collection of data from epilepsy surgery patients. Interactive workflows on high-performance computing and neuromorphic computing platforms. This is providing Europe-wide access to scalable and interactive compute services. The HPP part of high-performance computing is organized as the FENS research infrastructure. There are calls on the web, on the HPP website and on the ebrains website for giving neuroscientists opportunity to use this infrastructure. The neuromorphic computing is also available with 2 systems, brain scales based on physical analog emulations of neuron models offering highly accelerated operation, and the Spinnaker system, based on digital many-core architecture providing real-time operation. So the ebrains web platform is available at ebrains.eu. It is an entry point to ebrains tools and services, not only from the HPP, but also from other providers. ebrains is actively searching to integrate other tools and services as well. Thank you.